Hello everyone, reporting today for Fun Robotics Network. I'm Abbas, and with me here is Team 23521 DeSoto Technix from Olive Branch, Mississippi. They were absolutely fantastic this season. They ended 4th at MTI, deep playoffs run, did great at the World Championship, just all around one of the best specimen robots into the deep, and I can't wait to jump into their intake, outtake, all the parallelism they have going on, and more coming up on Behind the Bot. DeSoto Technix, I guess my first question for you guys is, you are very clearly a specimen specialized robot. At what point in the season did you make that decision to focus so much on that specimen game strategy, and why?
So we started the season wanting to be able to score both samples and specimens so we better match with any potential alliance partners. After our state championship, we decided to further specialize for specimens as we saw a lot more sample teams, and so we thought we'd have more likely chance of being picked as a specimen robot, and our robot better fit scoring specimens, so we decided to optimize for those.
Awesome. Yeah, now jumping right into the intake, it's very, very fast, just like the rest of your robot. Let's start with a high-level overview of the slides, the arms, the claws, things like that, and then we'll jump into the specifics.
So our intake is ran by 1150, geared 1-to-1, so allows us to have that fast extension. The intake is mounted on a coaxial virtual 4-bar, so we have one servo rotating the arm and one servo rotating the elbow. This allows us to have two independent degrees of freedom, which allows us to be very nimble and dispersal to pick up and also transfer, and for our sample capacity.
Yeah, awesome. So a couple questions there. Jumping into the claw, I see obviously the claw geometry to grab the outside of the samples, but also these like rubber pads or something on the outsides of the claw. What are those for? How do you use them?
Yeah, so those are baseball grip tape. So they're just for inside grip, since it's just friction on the inside of the sample. So yeah.
Okay, and so are you always grabbing the specimens with the samples by the inside, or also you can do from the outside in different situations?
Yeah, so it's actually mainly outside grip. For MTI, we saw that like outside grip is a lot faster, and at Worlds we're always trying to use outside grip as much as we can. So we mainly used outside grip. We also have inside grip if it's like up against a barrier, but we've gotten outside grip to like be able to pick up samples even when they're squished together. So yeah.
Awesome. Yeah, and one thing I think teams can learn a lot from is with these fast pickups. A lot of teams have been adding like roll servos or just like turrets so they can have that degree of freedom, but it's very difficult sometimes to use quickly. How have you guys made sure that you can use it super quickly and super effectively in your cycles?
So we came up with the coaxial virtual 4-bar system. Like, that was one of our first designs we thought we wanted to use, and it's worked very well for us throughout the season just because with the two axons, it's very, very fast, very simple, and it has a lot less moving parts than like turrets or any other alternatives.
Yeah, I guess more like from the roll so that you can grab specimens or samples that are at like 90 degrees or 0 degrees. Like from a driver perspective, how do you switch quickly between those, and what tips do you have for upcoming?
The control scheme is incredibly simple. It's using the left and right position of the joystick, and then it just goes straight down. Which the control scheme is quite simple. Some teams have when they have a turret, they have to have camera vision, etc., which further complicates it. But our control scheme is just very simple. It just uses the Y position of the joystick, and yeah.
So with a lot of practice, it allows for very fast alignment for samples.
Awesome. Now, jumping into that transfer mechanism, you guys have a couple different ways of getting that sample out of your robot. Let's start with just transferring out. I think you have both out the back and out the side. Is that correct? Or if you guys can explain it, that'd be awesome.
So we can transfer using inside grip and outside grip to our outtake to then score in the baskets, and we can also drop off this ramp here for scoring specimens. So that is transferring from outside grip. Transfer from inside grip. We can also go like that and drop off.
Yeah, awesome. So starting off with that whole outside versus inside grip, are those transfer sequences automated? Like it just depends how you pick up this sample and then that'll change what the transfer sequence is like, or is that also manual input based?
It is automated based on the position, whether it's inside or outside grip. The positions are pretty similar, but like they're slightly tweaked by a couple degrees.
Yeah, and as far as that side depositing goes, is that something you guys have had from the beginning of the season, or was it like a later addition? If so, what made you like realize that this is something that's really going to change the game?
That is something we added after Worlds. As we saw a lot of teams that had specimen robots, they had that sample pass through, usually with a turret or some kind of ramp. And so we saw we needed a faster way, as we used to have our intake transfer to our outtake and then drop it off. But since the sample is really high, it could bounce outside the observation zone. So this is where we found the need for this ramp here. So we were thinking between a turret and this ramp, but we decided to go on this ramp as it's completely passive and is independent of the intake. So we didn't have to make any changes to the intake. It was just plug and play, just make it to another position, and it drops that sample off completely independent of the outtake, so we can then pick up a specimen right as we drop it off the sample.
Yeah, that makes a ton of sense. Now, as far as game strategy is concerned a little bit, with this whole multi-transfer system, how do you guys decide when you're going to go out the side, when you're going to go out the back? What are some of the huge factors, and how can rookie teams learn from that?
So our strategy is we count the samples in the submersible that are accessible from the chamber side. We'll then subtract that from our nominal amount of specimens we want to score in a match. With that amount that we found, we'll get those from the rung side. So say there's 10 accessible from chamber, we want 15, we subtract that, we get 5. So we get 5 from rung. And then on the 5th one, we will use the ramp to pick up right as we drop off. We will then start parallelizing from the chamber. So we will then score a specimen, pick up a sample, drop it off, pick up a specimen, and then keep score, pick up, score, pick up.
Very cool, very cool. Now, talking about that specimen pickup off the wall, it seems like you guys are just incredibly consistent with that. I think there's 2 or 3 big factors there. What do you think contributes most to that consistency in those specimen pickups?
Yeah, so wait, can you go up? So one of the main factors that makes our pickup really consistent is we use this specimen aligner. So it just funnels the specimens down. It just funnels the specimens down right here. So before at Worlds, we didn't have this, and sometimes specimens would just get wobbled and stuff like that. But this time it just holds them right there, and then and then the outtake log can just pick up from above, and it's very consistent.
Yeah, and talking about the specimen aligner, what was the purpose of adding that springing into the system?
Oh yeah, so the reason why it's sprung is because we pick up specimens with the outtake like higher up, whereas its idle position is down, and we can't put the specimen aligner on the outtake because the claw goes right there. So when it's idle position, it just pushes it down, but when it's in the pickup position, the specimen aligner just goes up, so then for picking up the specimen.
Awesome, yeah, and I think I saw one match you guys had a sample get stuck in your robot, but then you were able to retract that specimen aligner down and knock it out. Is that an activated retraction, or is it just passively sprung?
So that is one thing we did to mitigate the risk of this design, as once we added the ramp and the specimen aligner, samples could get stuck in between the outtake slides. So this is just a manually operated servo right here, so it's an Axon Mini, and this just allows us to pull that down.
Very cool.
So you can see there we can activate it, and so that just allows the driver to pull that down, so even if a sample gets stuck, you can get it out.
Very cool, very cool. And also I see the touch sensor right there on that specimen aligner right next to it. Walk me through how you use that.
That's in use during auto. One thing you might have noticed is during autonomous, we really hit the wall going almost full power. So that just means that as soon as we get that, we instantly grab and then we'll reverse and go back to the chamber. We also have similar touch sensors on the front for detecting the chamber bar.
Awesome. Yeah, and as far as like consistency with that goes, was there any issues with having a touch sensor only on one side for that specimen pickup? I noticed you have them on both sides for that intake in the front.
That was mainly just for redundancy because, as you can see, we have these TPU bumpers and they're really quite beat up because it really slams into it. So we're just worried about one of them breaking, and that way, if one of them breaks, we still have a backup.
Okay, so as far as a code perspective goes, you're only reading if one or the other, lights up. It's not that both of them have to be triggered in order to continue your path. Is that correct?
Yeah, that's correct.
Awesome. Yeah, and talking a little bit about the software, when you do have these pathings, you mentioned that you rely entirely on those sensors to know when to move on. From like a pathing perspective, is it kind of you have your path generated to a point near the submersible wall and then you break from that and keep going forward, or how does that work from your code side?
We have the set points that are like a couple inches past where the field would normally be, and then once we see that, okay, the touch sensor's been activated, then we break from that and do whatever happens after we hit that barrier.
Awesome. Yeah, that makes a ton of sense. Now, talking a little bit also about just like the side plates and things like that, it seems like very heavily pocketed aluminum. Any concerns as far as strength or rigidity or anything like that goes, or would you encourage teams to like really pursue these super heavily pocketed designs?
So we started with using, this is our take on Ferrani's style pocketing. We did this mainly just for weight reduction, and we would just fact check it with some of our mentors to make sure that it would be strong enough. And then since we liked the look of this pocketing, that's why we also 3D printed, or we pocketed all our 3D printed plates. So it's mainly just for weight reduction, and it's really up to the team's need if they need to reduce the weight at a time of how much pocketing they want to do. We did increase the pocket sizes from a V1 to a V2 robot to reduce more weight, and this also allows us to access the inside of the robot more easily in places that are hard to get to.
Sure, and as far as weight goes then, how heavy is this robot?
Is around 13 kilograms, 29-ish, 28,
27 pounds. Yeah, well, DeSoto Technix, thank you guys so much. You've been just absolutely fantastic every single season. You know, MTI last year, MTI this year, super strong performances each time. Can't wait to see what you guys bring for our upcoming game in just a few months. Reporting for Fun Robotics Network, I'm Abbas, and this is Team 23521, DeSoto Technix. Thank you.
Thank you.
Thanks for having us.